I'm representing Atkins here from the architectural studio. I want to show you a bit of an example of how working in Atkins can actually trigger some interesting ideas. Atkins obviously is a very, very large multidisciplinary firm. And we have obviously people doing all sorts of things, building or non-building related all over the world. And I want to show you one little example of when you put people with different backgrounds or different things that they do together in one space, there are actually some very interesting ideas coming out for us as architects. So this is work that we have a little team in the UK who have developed a tool, a software tool that can actually look into pedestrian modeling and actually simulate the way people actually behave when they walk through spaces. Now, this has not been developed with any sort of building design in place or in mind, but has been developed more for crowd control, for analysis of space as a very sort of academic exercise, and also for, well, I suppose, for sort of railway projects. Now, this is, for example, this is what you see here is actually a map of Leeds in UK, and this shows simply that. Is it the pointer here? Yeah. Basically, it shows in a very numerical, analytical way that if you have a spot somewhere on a map or in a sort of built environment, and you sort of shoot out the rays where the people could see, you can get an analysis of how far people would actually move and what the behavior would be. Now, this is interesting because you can actually take this to the next level and start simulating how space would be perceived by people as they walk through that space. And of course, this can go on and start creating a very interesting pattern and actually predict how many people would be or what the percentage of people would be as they move through space. And you can predict accurately the number of people going through your city or through your space. Now, this was an academic exercise, as I said, by a team that we have in the UK, and they used this specialist software tool which they have developed on their own. And when they came to Hong Kong, we actually then started looking into sort of, well, that's a very interesting thing. How can we actually commercially apply this in our environment here for the project that we do here across Asia? Now, the first opportunity where we actually started looking at this, and I'll show you in a minute how we actually apply this on a building. This is a project that we're currently designing or have designed. It's under construction now. It's a mixed-use development in Chongqing. It's a 400-meter tower, hotel, and offices at the bottom, but also a very large shopping mall right in the center of Chongqing. Chongqing, if you've been there, you may know it's a very, very busy, very lively city. And sort of open spaces are actually very, very, very much embraced and used by the population there. So we have this big plaza here, right in the center of our development, with a big shopping mall around it. The shopping mall is, of course, it's an inner city space, an inner city plot, fairly dense. So we're looking around 6 stories of retail above the ground, a very large amount of basement retail, which is actually being used in Chongqing because of its topography. You have a lot of circulation, really, really crowded places going on in these pedestrian subways. Also, this actually connects straight into a subway station, which is being built just a couple of steps away from our site. And we started using that tool that the UK office had developed by actually applying this and see how we can actually use this to predict the pedestrian movement through our shopping mall. Obviously, the background being that shopping malls in the city obviously always have the dilemma of how can we predict or how can we control the number of people coming into our shopping mall. If it's a very tall shopping mall, how can we ensure that people actually use and go to all the shops? So as a developer with commercial interest, you can get the same rental income from all the shops, ideally. So we've used this tool saying, okay, we've got a very big plaza here. We look at we use the same sort of algorithms, and we try to see what happens if we sort of predict what people would be see and how many turns they make to go through the shopping mall. And by applying that principle, we were able actually to predict fairly accurately and the number of people going into the mall. We can see the ground floor, we can see the basement levels, and we can actually predict fairly accurately that the number of people and the percentage of people that are coming through the space. Of course, this movement or these turning of people and the visibility of spaces, of course, can be then directly translated into the visibility of shop fronts. So looking into sort of more accurate planning exercise, we can actually say that certain shops throughout the whole shopping mall have a certain percentage of number of people that see them, and therefore actually this could be equated to a sort of commercial value for each shop. And we also tested that sort of in a sort of three-dimensional way, where we sort of looked at a very large atrium space, which we can see here sort of peeled off as a cross-sectional illustration, and we can see how visibility is projected across all these shop fronts. So that was a very interesting tool, and it actually helped us evaluate our design, not only evaluate, but also iteratively change the design to optimize or to maximize the visibility of all the shops across the shopping mall. The same then, of course, has been applied sort of, has been useful in terms of positioning elevators, escalators, and everything to sort of facilitate the movement up through the shopping mall. And of course, eventually, this of course effectively helped us to predict the actual footfall of the mall and basically, measure the commercial value of all the units. And this, in the end, of course, has led to a very successful shopping mall. Well, we will be seeing whether it's going to be successful. It should be, but this is under construction. And here you can see the final illustration of this project as it's being built at the moment. Okay, that's all. Thank you. Thank you very much.